Nonlinear econometric model, transformation of variables. Nonlinear relationships are more plausible than linear ones for many economic processes. One of the limitations of linear regression analysis is implicit its very name. It can be used only linear equation where every explanatory terms except of constant is written in the form of coefficient multiplied by variables. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 and beta k xk plus epsilon. Equations such as y is equal to a plus b divided by x and y is equal to a times x to the power of b are nonlinear. Given that of x and y, how could estimate the parameters and be in this equation? Actually, in both cases, with a little preparation, one can use linear regression analysis after all. First, note that one linear in two senses. The right side is linear in variables because the variables are includes exactly as it defined rather than the function. The right side is also linear in the parameters since it consists the weighted sum of this as well. The x variables being the it says time. For the purpose of linear regression analysis, only the second type, the linearity is important. Nonlinearity in the variables can always be sidestepped by using appropriate definition. For example, suppose a relationship where of the firm by defining every function of variables through that the relationship can be written in linear form. This type of transformation only cosmetic, and you usually see the relationship equation present with the variables written in the nonlinear form. This avoids the need explanation and extra notation. On the other hand, and equations such as 3 for function is nonlinear in both parameters and variables and can be handled by the mere redefinition. We'll discuss the problem of fitting relationships that are nonlinear in parameters in the next section. In the case 2, however, all we have to do is to find z is equal to 1 divided by x equation now becomes y is equal to b1 plus b2z, and this is linear. Replace y on the constant term in the regression will be estimate by using ordinary square covariance will consider variables y, z, and divided by variance of instead of x, we'll use that. So, next method of estimate parameters of nonlinear regression, logarithmic transformation. Can we use this method when we estimate our function such as y is equal to 8 times x to the power of b. So in this case, we can algorithm both sides. So, for example, decimal logarithm. Decimal logarithm. We can write as sum of logarithms and b times logarithm. So in this situation, we can define logarithm through y, for example, and we'll obtain linear model. And parameters of this linear regression we can find it by using ordinary squares of and divided by that. So when I see such definition, you can immediately see that elasticity of y with respect x, so b, coefficient of b of power model is the elasticity of y with respect to x is constant, and so easily demonstrated. So for example, formula of elasticity by x to x, it's derivative of function to x and times x mean divided by y mean. So if we have our function, derivative of our function a times b times x to the power of b minus 1. So the power b minus 1 times x divided by y. In our case, power function, so a times x. And so b times x, b minus 1 times, we can so plus 1 minus b. So p case 0 because can subtract. So elasticity is equal to b. So for example, if you see an angle curve of the firm, y is equal to 0.01 times x to the power of 0.3. This means that the income elasticity of demand is equal to 0.3. If you're trying to explain this to someone who's not familiar with economic jargon, the easiest way to explain is say that 1% change in x will cause 0.3% change in y. For example, to semi-logarithmic model. As a common functional form is given by equation y is equal to a times exponent power 2 of bx, and here b should be interpreted proportional change in y per unit change in x. Nonlinear regression, y is equal to a plus b and x times b times x to the power of c. You wish to obtain estimate of a, b, and c given data y, x, and there is no way of transformation to obtain the linear relationship, and so it's not possible to apply the usual regression procedure.